we will see Young's experiment which proved that actually the fringes are made by superposition of light. Not only that, we can find out what is the width of the fringes, on which quantity this width of the fringes depend, and many other related issues. So, what was the arrangement in Young's apparatus? There is a cardboard which has got two slits, and these slits, you can say, a very narrow slits. Just we cut with the blade and a slit is made. Like that, there are two slits. The distance between the two slits is also very small, and this distance we call D. Here, this is the distance between these two openings. Now, we want this to become coherent sources of light, and for that we use the split method. That is, here we start a source of light, then the wave fronts are moving towards the cardboard, then at this point one wave front become an independent source, and at this point a point of wave front become an independent source. So these two secondary sources are made by the wave fronts of this primary source. So the waves generated by this and this will have similar frequency, wavelength and speed. So we will say they are coherent. So these two sources give coherent light. So wherever we get image of the slit, that brightness of the image will be consistent. That is assured. Now, here this point is, let us say, this is a point C. This is a central point O. Now, C is such a point which is equidistant from S1 and S2, equidistant from S1 and S2, and at that point the superposition is the constructive superposition. That means from S1 the crest is reaching here, S2 crest is reaching here. That is the point C. We have not chosen the point C, we have chosen that point where brightness is maximum, and that is our point C. Why it is maximum there? Because it is equidistant from S1 and S2, and both the waves has got path difference 0. So C is the point. We start from this, the description. So C is such a point. So there is a superposition because the path difference is 0. So C is maximum brightness. We can call it central bright spot. Okay. Now, if this is central bright spot, what should be the brightness at point P, which is at distance x from C? P is a point at distance x, okay, and we have to find out what is the brightness at this point. How can we find out? We can find out what is the path difference at point P. If we can find out the path difference, then we know the conditions. If the path difference is multiple of lambda by 2, then the brightness is 0, and if the path difference is multiple of 0 or lambda, 2 lambda, 3 lambda, then it will be the bright. Okay. So, how to calculate path difference? Now, path difference between what? From S1, the waves are going, this. Waves is going and when it reaches P, what is the length of the path it has travelled? Answer S1P. S2 is the source. From here there is a wave travelling and it reaches point P. What is the length of the path it has travelled? S2P. So what is the difference between the two paths' lengths? So P is a point at distance x from C. The path difference of two coherent lights from S1 and S2 is S2P minus S1P, S2P minus S1P. This is the path difference. Now, this path difference, if it fulfills the condition of constructive superposition, then it is bright. If it fulfills the condition of destructive superposition, then it is dark. Okay. So this S2P minus S1P we convert into certain fixed parameters. Which are those parameters? That is the distance between slit and the screen, the distance between the two slits D, color of the wave which has got a particular wavelength lambda. So all these three are having effect on this x. So we will translate x into terms of d, d and other things. Okay, see how we can do it. What is the path difference? S2P minus S1P, and we apply a little bit of energy, a little bit of geometry. Let this point be M and this point be N. S1P can be written as square of S1M plus PM square, and we start from this point. We write an equation this way: S2P minus S1P multiplied by S2P plus S1P is equal to S2P square minus S1P square. A very simple relation of algebra. A square minus B square is A minus B, A plus B. This S2P minus S1P, this is the quantity required by us, which is path difference. So we will keep it like this. Now, this is left hand side, this is right hand side. The right hand side we are doing certain operations, that is S2P square. S2P square, we take a triangle S2P and S2, this triangle. In this triangle, S2P square is square of this plus square of this. So that is S2N square, S2N square plus NP square minus S1P square is equal to S1M square, S1M square plus MP square, MP square. Now I convert them in the form of capital D and small d. S2N, S2N is capital D, this is D square plus NP, NP. Now this width from this to this is D by 2. And from this point to this point is x. So Pn is equal to x plus d by 2. So this is x plus d by 2 square minus S1M. S1M is again d square minus into plus minus, and MP this. MP is equal to x minus this distance which is d by 2. So this is x minus d by 2 whole square. Okay, let us solve this. D square is cancelled, x square is cancelled, d square upon 4 is cancelled. So what do we get here? xd, and here we get minus into minus plus xd. So this is equal to 2xd. This has become like this. Now come to left hand side. S2p plus S1p. S2p plus S1p. Now d is the distance between screen and this opening. Practically when we do this distance is very small and this distance is very large compared to this distance, and this height is also very small. So practically this distance and this distance, when it comes to addition, all these three are approximately same. When it comes to difference will be there, but when it comes to addition, like if this distance is equal to say 712 millimeter, this distance is equal to 713 millimeter, this distance is equal to 712.5 millimeter. If you do the addition, then it will be 2137. Yes, 2137.5. But if you take all 712, then the total will be 2136, which is almost equal. If I write it 2136, what is the error? Answer is error is only 1.5 out of 2136, that is 0.005%, which is negligible. So when we are doing addition, then very close quantities we can take as equal, but in the difference we can't do. That we have learnt in class 11th when we were doing measurements. Okay. Now S2p, S1p, for addition purpose both can be taken. S2p approximately equal to S1p approximately equal to d for addition purpose. Here we can write it as 2d. And S2p minus S1p we are not touching, because this is our path difference whose value we need to have is equal to 2xd. So path difference S2p minus S1p, path difference is equal to, take it on this side, and what do we get? D upon d into x. This is the path difference formula. So path difference, when we are increasing the value of x, path difference goes on increasing. Yes, we can very well understand here both the sides will be equal, S1 and this. But when we go up, this side goes on increasing in length and this side also increasing, but this increase less, this increase more, and the path difference goes on increasing. Now we know the condition. If this path difference is multiple of half lambda, then it will be a dark point, and if it is multiple of lambda, then it will be a constructive superposition. And once we have got this formula of path difference, we will use this as path difference, and proceed further. Point P. P is a bright point. If d upon d into x is equal to 0, lambda, 2 lambda, general formula n lambda. You understand this? If you don't see, please see the previous lecture where we have set this condition. For bright spot, the path difference should be integral multiple of lambda. So, what should be the value of x? X, transfer d by d on this side. So, this will be n lambda d by d. This. And what is the n? N is integral number, and from where should we start it? So we recommend that here we should start n is equal to 1, 2, 3, 4 and not from 0. Why? Because when we say n is equal to 1, then it is lambda d by d and we get bright fringe number 1. Where is the path difference? 0. Answer, at the central bright. What is the number of this fringe? So this has number 0. We don't give it any number. This is number 0. Then after this, the first bright will be made where path difference will be 1 lambda. So here, how do we get 1 lambda? Answer, if n is equal to 1. Nth bright fringe at distance x n bright, which is equal to n lambda d by d. This is formula of nth bright fringe. If I ask you, I am using orange light which has got a particular lambda. Okay. The screen is at a distance 1 meter, right? 1000 millimeter. This distance is equal to 4 millimeter. You got the D, you got the D, you got the lambda. Now I am asking you, where will be the 17th bright fringe? In the previous lecture we have seen the fringes will be alternate. Bright, dark, bright, dark, bright, dark. This is central bright. After this central bright there will be a dark. Then there will be a bright. Why? Listen carefully. Here, what is the difference of the path? 0. When we move them little up, how much is the difference of the path? Lambda by 2. When it is lambda by 2, what will be the fringe here? Answer, dark. Again, move up, the difference has increased and now it has become lambda. If it has become lambda, then what we get here? A bright fringe. Here. Move further, the difference has increased to 3 by 2 lambda, which is a odd multiple of lambda by 2. Then the fringe will be again a dark one. After that, move further, the difference goes on increasing, increasing, increasing. Then the difference will be, say, 2 lambda and it will be a bright fringe. In this way, we get bright, dark, alternate. So, we are getting alternate fringes this way. The same downward, and this is central. This is number 0, this is first bright, this is second bright, this is third bright, like that. This will be first dark, this will be second dark, this will be third dark, and so on upside. Similarly, this is first dark downward, first bright downward, second bright downward, third bright downward. So there will be a series here, there will be a series here. So what is the distance of this? If I ask you that this is, leave this number 0, after that if this is the, say, 7th bright fringe. So what is the value of x? What will you do? You will put here 7. Then lambda d by d, that gives you the distance. If I ask you what is the distance from the central bright, the distance of 9th dark fringe, 9th dark fringe. So you will take the formula of dark and put there 9. We will make that formula. Here we have got the formula for bright fringe x. Now we will see what's the formula for dark fringe. Condition for, this is condition for bright. Now P is a dark point. If dark, bright, if path difference d by dx is equal to, this path difference, it starts from lambda by 2, 3 lambda by 2, and this is n. We want for the first, we want there should be first. So we will write n 2n minus 1 lambda by 2. This is the general formula. So for the first brain, it should come lambda by 2. Put here 1. So if we put here 1, this is 2 minus 1, 1 lambda by 2, that is the first fringe. So x for nth, x for nth dark fringe. This is equal to, transfer this 2 on that side. So this will be 2n minus 1 lambda d by d, and here 2. This. You can say this way, lambda d by d, lambda d by d. This is n 1, 2, 3, 4. This is what? When you place it 1, then it is 1 by 2, then it is 3 by 2, then it is 5 by 2, like that. This is x. We start from central. Put n is equal to 1. N is equal to 1, and this will be lambda by 2. If we put here n is equal to 1, this will be lambda. So which will come first? Naturally, lambda by 2 height will come first. Lambda by 2 value of x will come first. You keep on increasing. So first there will be dark, then bright, then dark, then bright, then dark, then bright, and this is nth number distance. The distance of nth number of the fringe is given by this formula, and this is multiple of lambda by 2, this is multiple of integral lambda. So here we get it this way. So this experiment was shown by Young and it was shown in the lab. Once it is observed in the lab, then there was no need of proof. That was the proof itself that fringes are made, and how to explain. The explanation was already done by Huygens. So with this experiment it was proved that Huygens wave theory was correct. And that was a big thing in physics. the complete theory of Newton, that is corpuscular theory, that light goes in corpuscles which goes in a straight line like a bullet, that was rejected. Now, how the light was going? It spreads like waves of water in crests and troughs like this. So, this was how it was established by this experiment. With this experiment, we are also able to find out the width of bright and dark fringe. To find out the width of bright and dark fringe, first we define that how we understand what is meaning of the width. So, we will write here formula: width of bright fringe is equal to n lambda d by d. X for nth fringe, dark fringe, is equal to 2n minus 1 upon 2 lambda d by d. Okay. We make a graph for the brightness versus this distance. Here is the point C, central point, and height will show the brightness. At point C, the brightness is maximum. Now, I will make it a little bit here. This is point C, and here the brightness is maximum. If I go a little away from this, then what will happen to brightness? Answer: the brightness will decrease, because the difference will not be exactly 0. It will be slightly different. So, but it is not lambda by 2. So, when the first distance 1, this is half lambda d by d. This is the distance half lambda d by d. Lambda d by d, half. So, this will be the darkest point on this side, and this will be the darkest point on this side. What is the distance? Lambda by 2 d by d. Now, this is dark, this is maximum bright. What about this point? This point has brightness, darkness, only this much brightness. This point has this much brightness, this point has this much brightness, this point has this much brightness, this point has this much brightness. So, when we make a graph, we see there is a graph like this. So, then where is the first bright? First lambda d by d. This is half lambda d by d, and this is 1 lambda d by d. Lambda d by d. This is again a very bright point, and here brightness is this much. This is brightness. So, from this point, at this point, brightness start increasing, maximum, decreasing, minimum. So, we make a graph here which is like this. Again, it is like this. Similarly, on this side, half lambda. Then, this is 1 lambda. At 1 lambda, it is maximum. Again at half lambda, it is minimum. Again at half lambda, maximum. Again at half lambda, it is minimum. So, this is our brightness versus distance from the central point. These are all equal. Brightness, and these are all equal distance. So, this has become a symbol, a trademark for interference fringes. Now, brightness, and what is this point? Dark. This point is how much? 3 lambda by 2. d by d. This is 5 lambda d by d. So this is dark, this is dark, this is dark, this is bright. How much is this? Lambda d by d, lambda d by d. This is bright 1, this is 2 lambda d by d, this is bright 2, and this is 3 by 2 lambda d by d. See, every half lambda there is a difference. Here the difference is 0. After half lambda it is dark. Again after half lambda this is bright. Again after half lambda it's dark. Again after half lambda it is bright. That is what is said by our calculation, and that is what we see practically. So that means wave theory is calculating correctly. And this is the interference fringes. This was shown by Young's experiment, and now we have come to the topic width. Width of the bright fringe from dark to dark, from this dark to next dark. This is width of the bright fringe. Here this distance is this much minus this distance. If you do this minus, 3 by 2 minus 1 by 2 is equal to 1. So width of the bright fringe we get as lambda d by d. Again, width of the dark fringe. Where is the dark fringe? This is the darkmost point. This point is the brightest line. This is the next brightest line. And brightness decrease, darkest, and brightness again increase. So this is again maximum dark, and this is taken as width of the dark fringe. Bright to bright. And how much this is? 2 lambda d by d distance minus lambda d by d distance. This is equal to again lambda d by d. You can do this minus here, anywhere. It will come same. So width of the dark fringe lambda d by d, width of the bright fringe lambda d by d. That means their widths are similar. Okay. What is width of the central bright fringe? Central bright fringe, half lambda here, half lambda here. So half lambda here, and what is this width? That is again 1 lambda. Width of the central fringe. This is equal to again half lambda by 2 multiplied by 2, lambda by 2 multiplied by 2, that is lambda d by d. So we find whether it is central fringe, whether it is dark fringe, whether it is bright fringe, all are having similar width in interference fringes. So these fringes are made with how many sources? 2 sources. Now once we have studied it, there are many conceptual questions on this. What type of questions? The dependence on different quantities, how it makes the difference, how there is a difference of brightness, width, and etc. That we will see in the next lecture. Thank you.